Hello all and welcome to this final video in this short series on matrices. Today we'll be looking at how to divide matrices as it's written there in a sort of mini quotation marks, and also using matrices to solve equations. So let's first look at, and we touched on this in the previous video, but let's look on this whole idea and why I've got those marks around dividing and why I'm sort of saying in a different tone, is that we can't actually divide matrices. We use this thing instead called the inverse to do the same operation. But let's have a look at, again, just properly where this comes from. So if we look at a regular algebra equation that we're trying to solve, if we have ax equal b and we want to figure out, and this is find x, the problem, well, we use inverse operations where we can divide this side by a, divide this side by a. Those cancel, so we get x is equal to b divided by a. Now, you'd think, okay, let's just do that with the matrix. I have it in matrix form written over here. We have some matrices a, x, and b. So I want to divide by a, so I want to divide by a. They cancel, so I'm left with x is equal to b divided by a. Now, we don't have a process to divide by a matrix, but we have, as I showed you in the last video, we do know how to find the inverse of a matrix. Well, why is the inverse handy? Well, if we sort of break this b divided by a out, we can say x is equal to 1 divided by a times by b. And we know that 1 divided by a, or 1 divided by anything, we can rewrite that knowing using index laws. We can write that as a to the negative 1. We could 1 over 5 is the same as 5 to the negative 1. 1 over the matrix A is equal to the inverse. And all of these, a to the negative 1, 5 to the negative 1, they're all the inverse of it. So, and we found that, so we can now write this as times by b. So that's the whole reason why we had the last video, is that instead of dividing by a, we're going to multiply by the inverse of a. So in the previous video, that's why we were finding this inverse matrix. So whenever you're asked to divide this matrix by another matrix, this is the process you have to use instead, is this idea of multiply by the inverse. Now, why is there some situation in the world that requires you to divide matrices? Well, let's have a look at that. It turns out whenever you have simultaneous equations, and if we write them where, and this will be a key thing that we'll touch on later, but you just need to write them with the variables in the same order, so the terms with the x's come first, the terms with the y's come second, or whatever variables it is that you're using, write them in the same order. You can rewrite this into this form of a matrix. So we can write in matrix form where the first row is the first equation and then the second row is the second equation. And then after that, if the terms are in the correct order, you can actually break it out. You can break the x and the y out and just leave it as a first matrix, this matrix A, which is full of the coefficients. Matrix X, which is the variables. And then matrix B, which is the solution to the two equations. Solution, answer. It's technically not the solution. We're trying to figure out what x and y are later, but we can break these two equations down like this. So we're now left with this thing, ax is equal to b. And we just showed you on the previous slide, well, you could rearrange these matrices to get x by itself, which is these two variables, which we are wanting to figure out if you're asked to solve these two original simultaneous equations. Now, simultaneous equations is not the only time you're going to have to do a division of matrices, but it is a great introductory example, and it provides you another way to solve all simultaneous equations. And this is essentially what your calculators do in the background. So if we continue on with what we've got this matrix equation ax is equal to b. we've got A as that, X as that, B as that. We can now rewrite it, and using this idea of inverse operations, well, if we multiply both sides by the inverse of A, the inverse of A multiplied by A gives us the identity matrix, which is this bit here, and the identity matrix we looked at in the last video is just 1. It just means 1 in matrix world. That means we're just left with X by itself on the left-hand side of the equation, and we're left with the inverse of A times by B. And so if we can find the inverse of A, which is, it's already done here for you, find the inverse of A, this bit, that's the inverse of A, multiply it by B, we're going to get a 2 by 1 matrix, which this is telling us our X and our Y. So there's a lot to unpack there, and I've scribbled all over it. But all we're doing is, let's come back to this. We're trying to rearrange a matrix equation, do inverse operations as it is, to get X by itself. And we get X by itself by instead multiplying by the inverse instead of dividing by it. And this was just a larger example of, we can also turn any simultaneous equation, we can write in matrix form. So there's a whole lot there. Let's, I should probably have these around in a different order, but let's get straight into an actual example, go through the working out. We're going to skip this one because this is one doing CAS, and as you can see, it is 3 equations with 3 unknowns, so I haven't shown you how to find the inverse of a 3 by 3 or anything there. So we'll come back, and anything this complex, you'll have your CAS, but we'll come back to it. Let's get into actually doing one by hand. So we have these two equations, y is equal to 3 minus 2x, and we have negative 6x minus 3y is equal to negative 9. And it says solve the following simultaneous equations using matrices. So first things first, you need to rewrite this where the order of the terms matches. So this is equation 1, this is equation 2. We need to rearrange equation 1, and you need to get both the variables on the same side. So we're going to take this negative 2x, bring it over to the left-hand side. So we now get 2x plus y is equal to 3, and then the other equation we can leave the same. So we get negative 6x minus 3y is equal to negative 9. We can turn this straight away if we think of what the coefficients are. We have a first matrix which has our coefficients. We have our second matrix which has the variables, and that equals, and then just the answer, or the right hand side. So let's put the coefficients in. The first one we have 2, and then the plus y, that is technically saying plus 1y. So we just get a 1, and you don't put a plus sign in there. Negative 6, so that's my coefficient, and then negative 3 is my coefficients. My variables in the order I listed them, reading from left to right, is x and y, and the answers were 3 and negative 9. And we can call this A, we can call this X, and we can call this B. So we have AX is equal to B. So we can say X is equal to inverse AB. There's a little weird thing here too. It's always done, you put the inverse in the front. Put the inverse in the front, or if we're trying to move the A, wherever... I'm just trying to think. Let's erase some of this. If we had AX equal B and we're trying to figure out what X is, since the A is in front, we're going to put the inverse in front on the other side. If I was trying to figure out, if I had another example though, if I had X, C is equal to D, and I'm trying to find out what X is, since the C is at the end, I'm going to put the inverse of C at the end. So whichever side the matrix that we're moving is on, we need to put the inverse on the same side of it. But almost all the time you're going to set it up where the matrix we move is on the left. So over here we're going to have the inverse on the left as well. So we've got, as I said, here, we had AX is equal to B, so now we get X is equal to the inverse of A times by B. So we need to find what the inverse is of A. So to do that, we need to find the determinant of A. And if you don't know how to find the inverse of a matrix, that was in our previous video, but the determinant of A is equal to 2 by -3 take away 1 by -6, so that's giving us -6 take away -6. I've done something wrong here. It's equal to -6 plus 6, which is equal to 0. Which means the inverse doesn't exist, which is a problem. Dividing -3 is -6. Why would I pick numbers that give us... I wouldn't have picked numbers that give us one that we can't get to a solution. Let me have a quick look at this. Yeah, I have. I've picked numbers that aren't going to give us a solution. Okay, let's change this. I'm going to change our original equation. We'll make it... It's not going to lead to some nice numbers, but we'll make it 2y instead. Say it's 2y. Just to make this possible. So we're going to be a 2 in there. That, so we get plus 12. We're going to get 6. There we go. So that's our determinant. So now we can write the inverse, which is equal to 1 on 6. And we need to flip the main diagonal, make the other diagonal negative. And this is where we're going to run into a problem. This is going to lead to terrible fractions. So inverse is equal to... So that's going to be -half, -1/3, -1/3, 1/3. So that's the inverse. So therefore we can write x is equal to our inverse, which was times by, as we had over here, it needs to be times by b. So we get 3, -9. And now if you do this matrix multiplication, which is in video 3 of this series, we have to multiply the row by column. So we're going to do, that will give us -half times by 3 will be -3 on 2. -3rd by -9, that would be 9 on 3, which is 3, so that's plus 3. And then we do the second row times by the column. Going to give us -1 minus 3, so that's going to finally give us -half plus 3, that's going to be 3 on 2, and that was -1 take 3 is -4. And if that's our x and our y, which was our original x matrix back there. So there's a lot in it, and especially there because that was not so nice numbers that ended up with fractions. But that's how you use matrices to solve simultaneous equations, and within that how we did the division. We didn't so much do the division, we just multiplied by the inverse instead. How are we? Up to 14 minutes. Let's look at this one quickly on our CAS. So we need to solve the following simultaneous equations using a matrix with the help of a CAS. So first off, I'm just going to make sure these are all in the same order. This one's missing a Z, so technically we would write this out as 2. And I'm just writing the coefficients, so I'm making up the coefficient matrix. -1, 4, 2, 2/3, and since there's no Z, it's 0. and we have x, y, z is equal to 2, negative 1, 3. So that's A, that's X, that's B. So X, our solution, is going to be the inverse of A times by B. So, how can you do this on the CAS? Well, we can store what A and B is, and then just get the CAS to find the inverse and multiply it for me. So I click once on the matrix button, and then click again, and it turns into a 3 by 3. So I'm going to go 2, 1, 1, 0.5, negative 1, 4, 2, 2 divided by 3, and 0. And I want to store that as A. So I use that button there, store it as A. Done. I need to store B. So press it twice, and then I just need to highlight those two columns and hit delete. I get 2, negative 1, 3. I want to store that matrix as B. So I've got A and B stored, but I don't need, my answer X will be equal to the inverse of A times by B. So I can just do A, the power of negative 1, multiply all of that by matrix B. There we go. My CAS tells me that X is equal to 9 on 5, negative 9 on 10, and negative 7 on 10. Or I can write X is equal to 9 on 5, Y is equal to negative 9 on 10, and Z is equal to negative 7 on 10, Z or Z. Rightio. So that's how we can do it on CAS. That's how we can do it by hand. You'll only ever be asked to do it by hand with a 2x2 matrix. And finally, we'll have a quick look at doing a worked an applied problem. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 220 people enter the fair and $550 is collected. Set up simultaneous equations and use a matrix method to solve for how many children and how many adults attended. Like with all applied problems, what you're being asked to find at the end is 99% of the time the variables that you need to let or give letters. So we want to find how many children and how many adults attended. So I'm going to let C equal number of children that attended, and I'm going to let A equal number of adults that attended as well. So now I have some variables, I can use them in this information. So I told 2,200 people attended, so the number of children plus the number of adults is equal to 2,200. And also I was told that $5,050 was collected. And that would have been for every child paying $1.5 plus every adult paying $4. That would give me the total amount. So I've created two equations now, 1 and 2. I can turn them into a matrix, like simultaneous equation version of matrix, where I have my coefficients. Now the C and the A, that's technically 1C and 1A. So I get 1 and 1, and 1.5 and 4 in my coefficient matrix. My variables in the order that were from left to right was C and A, and they equaled 2,200 and 5,050. So I now have a X is equal to B, so X is going to be equal to the inverse of A times by B. And let's actually change the A, because I've got a little case A. Let's just make it M. So mx is equal to b. I take the m over to the other side as an inverse. So we need to find the determinant of m. to be able to first find, and you could do this on your CAS, but let's do another one by hand. So the determinant of M is equal to 1 times by 4 take away 1 times by 1.5 is equal to 4 take away, and 1.5 is 3 over 2, so that's going to be equal to 2.5, which is the same as 2 times 2 is 4 plus another is 5. That's 5 on 2. So that's our determinant. So the inverse of M is equal to 1 on 5 over 2. And we flip the main diagonal, so that's 4 and a 1, and we make the other diagonal negative. And I've changed the 1.5 to just 3 over 2 to make working with fractions. So that is now going to be, so now 1 divided by 5 on 2 is the same as 1 times by 2 on 5. That's just 2/5. We get 2/5 of 4 neg 1 neg 3 on 2, 1. So that is going to equal 2 times 4, that's 8/5, negative 2/5. And the 2's will cancel, so that'll be negative 3 on 5 and 2/5. So that's inverse matrix M, so we can say X is equal to that we got, which is 8 on 5, negative 2 on 5, 3 on 5, 2 on 5 we had, times by 2200, 5050. Now, we could have left this fraction out the front. We could have put instead this here, and then done the matrix multiplication bit of it with, and having this 2 over 5 out the front, and then multiply that through. And that actually would have been, especially in Tech 3, that would be a smarter way to approach it, because you're having to do less multiplications with fractions, because like, what is 8/5 of 2200? And then what's negative 2/5 of 20? Like, we're dealing with a lot of annoying sort of fractions. So the other way we could do this is 2/5 by 4 neg 1, negative 3 on 2, 1. And we can do this matrix multiplication bit first and leave the 2 over 5 out the front, which we might do. Let's do that. That'll be a lot easier. So we're going to do 4 by 2200 plus neg 1 by 5050. And then we're going to do negative 1.5 times by 2200 plus 1 by 5050, which, let's leave the 2 over 5 out the front. 4 times 2200 is 4 2s are 8, 8, so that's going to be 8,800 take away 5,050, and 1/2 of 2200, well, a half of 2200 is 1100, so that's going to be negative 3,300 plus 5,050. That's going to give me 2/5 of 8,800 take away 5,050 is going to be 3,750, and 5,500 take away 3,300. Oh, I'm just going to do as like a year 7 maths takeaway. Need to borrow from that there. So why did I do that? I didn't need to do that. 0 take away 0 is 0, 5 take away 0 is 0, 4, put that, 10 take away 3 is 7, 4 take away 3. That's 5 there. 1,750. Okay, so I need 2/5 of each of these, so I need to divide each of these by 5. What numbers that are probably going to make this work? Got a 750 in it. Or let's just do a regular division. That's why you're taught these things, because sometimes you have to use them. 5 into 3 can't do, so 5 into 37. You can get 7 of them with 2 left over. 5 into 25 is 5, put 0, so a fifth of 370 is 750, so you're going to times that by 2. That is going to give you 1500. And then a fifth of 1750, 5 into 1 you can't do, 5 into 17 you can fit 3 with 2 left over. 5 into 25 is 5 and 0, so you get 350 times by 2 is 700. So there's our final matrix. A lot involved in this, which is equal to x. So we have CA is equal to 1500 and 700. So the number of children that attended was 1500 and the number of adults that attended was 700. And that's how you do it using matrices. A little bit longer video, but as you can see, these are tedious processes. In a test or something, you're not going to be asked to do lots of these because there's just so much involved. But you need to know how to find the determinant, you need to know how to find the inverse, and then you need to know how to do matrix multiplication. All three things are somewhat tedious, and they're all combined together. That's it. Yeah, so you just now have exercise 26E left. And yeah, that's it for this series, so hopefully you're going okay. If you have any questions, as always, email, put in Google Classroom, or put in the comments below. Thanks, and have a good night.